hoping to be able to test out here, okay? We're going to have to reconnect to PuTTY here, but we're going to be hopefully making some of this kind of interact. You can see Subversion in practice. Okay, so the second major topic for today has to do with this issue of version control. Version control, I would say, is less of a strategic investment than incremental development, and by extension, iterative development. What I mean by that is it deals more with things at a tactical level, sort of a processes and operations level, rather than at the level of success or failure at the large scale of your project, whether or not it meets user needs. Version control is sort of something that it's a best practice that is extremely useful for keeping yourselves out of trouble, greasing the wheels of the development process, helping it to go more smoothly. It's less likely to be fundamental to the life depth of your project than is incremental development. Incremental development is one of those things, if you don't do that, you're at real risk of being canceled. Okay? Not delivering value that the user is satisfied with. Version control is about getting our development operating efficiently and keeping us safe, which is always good for delivery. So, version control mechanisms date back decades now, and they were meant to deal with a set of challenges and frustrations that came up in the development process. And some of the sorts of use cases or stories associated with them are illustrated in this book. So, you know, someone might say, well, look, this code was working last night before the updates worked well. You know, think you're one day before shipping to the customer, things were just humming along, someone made some updates, and now it's not working. You might want to go back to that version as of last night. Roll back those changes. All we did is, you know, we added in the about dialog, and now the whole thing is hosed. The whole program is just hosed now. It won't even fire up. We don't know why. Let's roll back. We got the demo in and out. Could that be a real need? Yeah, it could be a real need. Okay, here's another problem. Okay, we might be shipping version 5 of our product, but some customer is calling us dealing with the old version of this. I've dealt with this before, and it's very awkward. Very, very awkward. This customer somehow got my number as a developer, and they're calling me directly. This isn't working. Yeah, help me fix this. And we're just relentlessly pursuing me about an old version of something that we weren't really interested in supporting. They're working with an old version, and generally you can't dismiss customers lightly, folks. I mean, they bought this thing. You have to support them. If you want them to upgrade to the new version, the way to do that is to make them a happy customer, a happy camper. They're not going to upgrade. They're going to go to your competitor if you don't keep them happy. And they're dealing with version 3. What's in version 3? Well, unless you have some way of kind of going back to version 3, going and looking what was it like then, you're kind of off the creek. So, you know, someone says, well, look, there's this new function here. You know, who added this? Foo-bars in our program. Who added it? I bet it was Osgood. Osgood added it. So before you jump to the conclusions, you know, normally we try to be innocent for proving guilty. As they say, one recognizes the lion by his claw. I hope you don't forever remember me as, you know, the professor of foos and bars. But we want to know who added this thing in. Where did it come from? When did it get added? Maybe it's taking a lot of time now. When I run a profiler, it's chewing up a lot of CPU cycles. Who added this thing in? And what's his job? Who should we go speak to about this? Particularly key if you have a large distributed development team. You've got people working around the country, around the continent, around the world. You know, these days, your teams that you have to work in may have people in India, people in Russia, you know, people in China, people in South America you're working. Who added this thing? Well, we used to have this function, foobar. It was Osgood's function. And it seemed to vacation right now. Well, he wishes. Can someone get this thing back? Where'd it go? So generally speaking, there's compelling reasons to keep old versions of code. We want to track changes, what was changed when. This bug has suddenly cropped up. What's changed? Yesterday it wasn't there, now it is. What's changed between those times? What code changed? That will give us a big clue as to where it might have come from. But we want to be able to go back to earlier whole versions of the software we might have released to the user. The problems become particularly acute when you have multiple lines of development going on at the same time. Suppose you're shipping, you shipped one version of it last year. You've done a total overhaul and have the next big version of it coming out now after some incremental changes. And you've got some work on an adaptation of it for a really big customer going on at the same time that has extra bells and whistles. How are you going to kind of keep those together? You don't want to just copy all the files from over to here, and keep them totally separate. If a bug's fixed in one, it may apply to the other. So how are we going to kind of keep these in sync while still allowing for their differences? And I would advocate folks, experienced software developers, even if they're working on something purely for themselves, purely a little utility to speed up some tasks that they're doing day to day, they often will want to put things in version control. Among other things, the code is safe off there. If your hard drive, it's safe off there. You could go back and restore something if the new version is not working. You could fall back to that, and you can identify the source of bugs more easily. So, for many years, people conducted a manual form of version control, and this depended on sort of personal self-discipline and conventions. If we looked at that, you might have, for example, use of names like this, .new, .older, .olderer, or something like that. But more likely, you might have something like this, foo version 1.c, foo version 2.c, etc. And you're working now with foo version 57.c. And you previously compiled the code to, the last one you gave out to the customers with foo 53.c. There's a couple issues with this. One issue is just sort of when you increment these numbers. You can compare successive numbers, but when you get lost in the space of names. So imagine creating a make file from what you've seen, that has 57 different versions of foo.c. It can be quite a nightmare. The problem is that, and people have refined this with minor version numbers, major version numbers, and so on, but it's still quite a mess. Another issue, even if you do that, you might want to change log. In what version of this did I add a certain function? Maybe you want to grab that. Sure, you can go grab that within there. But if it's a bigger type of change, you want to say you restructured the data structure. Maybe you can't grab look for one particular thing. So you keep a change log. Maybe you keep it in a notebook, or you keep it in some file saying when did I make a certain change, version 53 to version 54 of foo.c, I added in support for non-Unicode or for right-to-left languages or what have you. The problem is that this depends on a lot of personal self-discipline, which can wilt in the face of deadlines, and it depends on conventions that may not be clear to everyone, and no little bit of luck. So there's a better version, fortunately, and that's a version control system. Here, ladies and gentlemen, we have the computer do this work for us. Previously, in kind of managing this mess, we're doing a lot of bookkeeping. We're keeping track of which versions are out there. We're keeping track in our notebook of what they did. That's the sort of job a computer is meant for. And it's perverse. If we're keeping track of all this complexity in our head, that's the sort of thing computers are great at. That's the sort of thing for which computers are great. That is So, suppose multiple programmers are working on this project. How can we share this effectively? Putting all these things in one network repository is often a mess. If we have people from outside the company, it may not be safe. So the basic idea here, folks, is that version control is gravitated towards. And there's many such versions. You saw them referred by me earlier on an earlier slide here. So here, source code controls, SCCS, RCS, CVS. These were all back around 20 years ago. Subversion is probably the most popular type right now, but Git is giving it a rapid run for its money. And I suspect within another 5 years' time, at the most, Git will probably be dominant, if it isn't already, in certain segments. There's a number of others from other vendors, including Visual Source Safe, Code Warrior, also has some, etc. Okay, so these version control systems help us support multiple people working on a single project. And the idea is that they keep a single version on a central server, and basically they gate access to this. Now, doing this in a naive way with file sharing is a problem. With file sharing, for example, if there's only a single version on this server, only a single version that's maintained, it's easy to overwrite, you can't go back. People have worked on approaches to try to deal with the fact multiple people can be dealing with a certain file at once through locking protocols. I take the lock, I work on it, I return it, update it, and then I remove my lock. But it gets really, really messy. Okay, so I'm going to go and describe some more sophisticated ways for doing this, and then we're going to go into the way that you're going to be learning about or applying today, which is subversion. See, the idea behind one popular version control model is the so-called copy, modify, merge model. So here, both users copy a file. They create a copy of the file. They update it on their own. They upload your changes. And if one of their changes conflicts with another change, then you have to go merge your changes with the person's changes that were already updated. So I'm going to use a diagram, which was actually taken from this online site we referred people to, this redbean.com site, which illustrates it. So suppose we have a repository. We have two users, Harry and Sally. Okay? There is some file over there in the repository, some latest version of main.c. And both of them need to work with it. Maybe Sally wants to add some new functions, and maybe Harry wants to group the comment. So both of them go on their individual machines. They may be in the same room, or they may be in different continents, and they go and read this file down to their machines. Okay, they both edit their copies, and they end up with different copies, a prime in this case, a double prime, both of which are different than the original file contents. Sally writes hers back to the repository first, and she commits hers. So we say that she commits her version. She places it back in the repository, often with comments about what she did. So she might have comments at the time of a commit, as we'll see, which basically say, hey, I added a couple of these sort of methods, which serve to support users on small screen tablets or something like that. Harry then wants to go commit his changes, but the problem is when he goes to do so, he gets an out of date error. He's told essentially, wait a minute, you can't just slap your version over to the server. Why not? Why is it important that Harry not just copy his version over to the server? Yeah, because all of Sally's work is now gone. That's bad. It's bad. Sally's wasted an afternoon. So instead, Harry needs to be notified that, wait a minute, something's changed there already. You need to go and be very careful and merge your changes in with Sally's. Now, a lot of the time, that's really straightforward. They've modified different areas of the code. Again, Sally has added functions, Harry has improved commenting. No problem. You should be able to merge them together. In other cases, ladies and gentlemen, it gets more messy. Can anyone give a case where it might get messy? Yeah, they're editing the same function. They have modified the same code in different ways, in which case it gets tricky. And that requires careful thinking. And probably requires talking to both of them and figuring out how we're going to sort out this mess. In most cases, it's not that bad. So what goes on here typically is Harry will take his changes, A prime, and he will compare them to A double prime, Sally's changes. And he will create a consensus version that captures the best of both, captures the essentials of both. So he gets a consensus version, and he then commits his consensus version in an appropriate way. Sally then will typically, as part of her daily work, and this gets done, ladies and gentlemen, on a day-to-day basis at the least, she will update her code base. It's also called refresh her code base. She's working with a bunch of code. Maybe she's on to module B now. But, hey, module B may call off to module A in some places. And so she needs to get the latest version of that. And so sometime that afternoon, maybe she'll refresh her code base. A star comes in because that's the latest version, and she'll be working with that version. Okay? So what are some pros and cons? Well, some pros is multiple people can work on these files at the same time. There's a need to manually merge. Fortunately, we have tools that help us with that merging process. I've mentioned, and I think you folks have seen in the lab, a tool that really, really helps us figuring out what's different between two files and extension and how we can merge them. What is that tool? Diff. D-I-F-F. So diff gives a crisp, although sometimes arcane-looking, story about how two files differ. Okay? And these tools that we're going to be talking about automatically give us this ability to do diffs very quickly. Allow us to say, okay, the difference between your code and this code that's already been checked in is such and such, and they can help us merge these things. There are tools that help us merge as part of that. Okay? So let's talk about Subversion, the system that you're going to be using today as an illustration of these so-called source code control systems, or version control systems, or revision control systems. They go by all these different names. Subversion, as I say, is probably the most popular one out there. It is a centralized version control system, in contrast to Git, which is decentralized. And it uses this copy, modify, merge approach that we get. Git's approach is somewhat different, but there's a lot in common between the two. So Subversion replaced CPS, which was a quite dominant, very, very popular system in the past decades. And Subversion is open source and free, and it's tended to be distributed widely. And as I say, it's very popular. It allows us to go back to different versions of a project as it existed at certain times in the past. The costs of this are fairly modest, but we do have to maintain a repository. And we have to be able to adhere to certain conventions that prevent us from just willy-nilly going and using Unix commands to do whatever we want. So instead of using the mv command to change the name of a file, for example, or to shift a file around, we have to go through the Subversion tools. We have to tell the server, hey, we've renamed this file. We have to tell the server we're adding this file in to our project. And the job for doing that is quite straightforward, but it does require a little bit of commitment on your part. So I provided some resources here, and those going on to lab immediately after class will find these particularly helpful. So you'll notice that there's an O'Reilly Associates book. O'Reilly Associates being the creators of a great many extremely popular technical books. There's one book on Subversion at SPN.book.redhat.com that I would suggest that you take a look at. It's got lots very easy to follow, nice commentary. Okay, for the lab this afternoon, you're going to have to exercise a set of subversion commands. Okay? And I've thrown up here a list of subversion commands, which are going to be quite commonly used in day-to-day development. You're not going to have to use all of them, but there will be some. For example, SVN import, SVN checkout, SVN status, SVN add. SVN import takes an existing project, puts it into the Subversion server. SVN checkout allows a person, say in a different machine, to take an existing project which is already on that repository. It's already on that server, as I just called it, but repository is a better name. And let me get it. Let me get the latest version of it here. Yeah, check it out. Get the latest version of that machine. Okay. SVN status lets us know if we're in the middle of something. Which of our files how do our files compare with those in the repository? Are our files out of date? Are some of our files modified and not yet uploaded to the server, etc.? SVN add allows us to add a new file to an existing repository. So maybe we had foo.c and makefile before, now we add bar.c. We want bar.c to be part of the repository. SVN commit lets us commit our changes back. Remember, that's what Sally did. She committed her changes back. And this is not something you just include with one file at once. It might be with several files. The .c and the .h file would be accompanying .h file. SVN diff allows you to look at the differences between what you have and what's on the repository of previous versions, for example. SVN log lets us get a sort of list of past operations, and I could go on. But I want to talk about some of the concepts here first. I'm using some of these terms and kind of appealing to your intuition, but I want to give you a little bit of a sense of what we're talking about. So I refer here to a repository, and this is the name, the term of art for it. This is the name that you'll hear software developers use day to day. You'll hear our tech staff talking about it, the Subversion repository. This is a centralized store mechanism for Subversion. When it really comes down to it, it's located on a server and a certain database that it maintains. And in fact, as part of the lab, you get to see that database created on your machine. Any number of clients can access this repository, so it's a client-server sort of model in contrast to Git. And you access it through a URL, something that might be a HTTP repository. In your case, for your lab, for simplicity, you're going to be creating your own repository. You access it through file colon. I want to bring home something that's very important for you folks. It can cause quite a bit of frustration. Okay? If you have this reference file, you notice it's kind of similar to HTTP colon / this is file / If you had something in a certain folder of yours, maybe it's my folder / faculty /NDO885. You'll notice there's this third slash. What does this slash have to do with? This is the slash here. What is this slash from?
That's from the root directory.
Yeah, exactly. It's indicating the root directory. So it can be confusing to people. They think all that's needed is those slashes up front. In fact, if you're referring to something in an absolute path that's coming down from the root directory and so on, there may be a third slash there. So you should be aware of that. That may trip you up unless you're aware of it. This repository actually incorporates a file system tree. It actually incorporates a tree that stores a bunch of information on the files that you have in your project. This repository stores them, and it stores their different versions. It remembers every change made to this, okay? It's like the what? That has a long memory. Yes, thank you, and a long trunk. Thank you. Okay, so we have a repository. The files of all different versions are up there in the repository. Generally, though, we're going to have many publishing on the repository in all its different versions. Okay? So your working copy is just an ordinary directory tree. It's just it's got folders in it, and you can fill with files in the repository by doing a read. You do a checkout. You say, hey, I want to get all these files from this project to this directory. Okay? And in the process of doing that checkout, it will create an administration subdirectory .svn. Okay? You can then publish and write changes to the repository by doing a commit. Okay? Now, there's many processes you'll be using day to day, and I referred to some of them earlier. One of them is an update. So you do an svn. So this is an argument to the svn command. You'll do svn update, for example. What does update do? What's the synonym I use for it? It refreshes your code base. So in other words, suppose Sally has updated some files on the server. You want the latest versions of those files that she's working on. She's been working, you know, that she was here yesterday while you were out, and you come in and you want to get the latest version, you do an SVN update. Okay? And this causes a read from a repository. Okay? So those are changes that someone else has committed. Another thing you might do is an SVN commit. Okay? And this would commit changes that you've made back to the repository. And it does so, ladies and gentlemen, in an atomic way. Now, that may sound scary. It may sound downright malevolent. But it has nothing to do with mushroom clouds or sort of global conflict. What do I mean by, if I say it's an atomic, what do I mean by atomic? In computer science, we use the term atomic in a different way than our colleagues in computer science. What do I mean by atomic? It's indivisible. That's the best way to think about it. Yeah. It is indivisible. Either it occurs entirely or it doesn't occur. There's no data corruption as part of it. It doesn't kind of get halfway through and say, oh, I ran out of space. Tough luck. I overwrote these files and not these others. It either is successful in all its operations, or if it encounters an error anywhere along the way, a network has been dropped, the disk is full, the disk is corrupted. If it encounters that error anywhere along the way, it will clean up it so it's as if nothing has happened. You may ask how that happens. You may think that sounds like magic. It turns out we have ways in computer science for making that happen. And it's nuts, because if do errors happen? Yeah, they happen big time, folks. They happen quite a lot, and they often happen when you would least like them to. Lots of people are coming to your site. And by making it atomic, it allows us to, even if we can't grant the request, make sure we're not corrupting anything. We're not dying in the middle of something. We're not dying in a way that's messy. Okay? So this is a pretty strong property, and SVN adheres to it. Okay? So even if the machine that you're checking into, you're committing to, even if that server goes down in the middle of it because of a power outage, you won't have lost anything. It's not going to get halfway through writing a file and only half the file is written. It either writes entirely, the whole, all your updates, or not at all. Okay, each commit creates a new state of the file, the whole file system tree called the revision. It's very important you realize these apply to entire trees, not to individual files. So when you go check something in, it's like it creates a new state of the project. I commit, after my commit is done, the whole project's in another state. What was there before, but my change is after. Now it's in a whole state. Someone could say, I want to see that state of the project as a 1:05 yesterday afternoon. And they could see that. And that revision number tells us, it gives us sort of identity testing. The identity of it. Okay? It's a unique number. And this applies to an entire, as I say, an entire tree. And then by doing an SVN status, I can see, and you might do SVN status minus U minus V, which asks you to compare your current status with the latest status. Why do I have to specify that has to be the latest? Well, because there's many. Remember, the repository stores the entire history. We might want to compare our current with what it was yesterday. But instead, we can do SVN status minus v, minus u minus v, status minus u minus v, and that tells us this is a v as in Victor, and it tells us, compare my current status, what versions of the files are in my little directory here with what's the latest thing which is on the server. And so, for example, you might have something that's on your system that you're working on that's bar.c. Perhaps you haven't modified it yet, so bar.c as of yesterday. On the server, there's a new version of foo.c and a new version of makefile, for example. Actually, for SVN status minus u minus v, it would show two numbers for each of these. What's on your directory and what's on the server. So it'll actually show both. Both numbers. Okay, in my directory, I have version 1, but on the server, it's version 2. My directory, I have version 2 of bar if I've modified it, but there's only version 1 on the server, etc. Okay? So a couple of things to keep in mind here. Doing a commit of a file does not force other users to do an update. So just as I commit something doesn't mean that all of you get it immediately. You can decide when you want to get my changes done, when you want to refresh your code base. Maybe you're in the middle of testing, you want to make sure it's working fine with the version you have in your machine, and then you'll get my latest changes and see if it works fine with those. Okay? So doing a commit does not force other users to do an update. And doing a commit doesn't involve getting the latest thing from other users. It's an SVN update that allows us to refresh our code. Okay? And what that means is that sometimes you can get sort of a mixed collection of files on my server. Now, I provided a set of commands here, and I just want to narrate them. I was hoping to do them interactively. There's not going to be a lot of time for doing this, but perhaps I will actually try. Oh man, especially under this situation. Do bad things happen? Yeah, bad things happen when you least want them. Okay, so if we go to 2.14 here, I'm going to go into bash, and I'm going to create a shell variable called SVN repository. Okay, and if I do set, I can go see SVN repository has this /faculty/osgood, right? I'm going to then create a URL. This is going to be a shell variable that actually gives the URL I'm going to refer to, file : such and such. I'm going to use that in referring to Subversion, okay? And I'm going to now create a repository, folks. I'm going to create a repository at this location, my home directory SVN repository, okay? Note that this uses a different command. This is an SVN admin command. It's saying, hey, go create this repository. That's not something you do day to day. That's like creating a whole project, folks. Not just sort of different branches of a project, but it's like creating a whole line of work, okay? Following that, I now have a repository. So I could go take a look, for example. Actually, it's in my home directory, so I'll go look there. I could go look, this is what's in there. So in other words, if I'm looking at this SVN repository, this is what I see inside it. I can see there's a lot of things inside of it here. So there's actually, for example, a database directory, and you can see there's a bunch of stuff in there. So it's a whole little file system on top of itself. So I'm now going to create a folder called example2src, okay, which is, oops, I'm gonna create that, and I'm going to here Okay, I created that. And I'm going to go into that directory, example2 src, and I'm going to create a bunch of files. What do you think they're going to be called? Well, okay, you guessed it. So you notice that these are not particularly meaningful. This is the make file, right? If I do an lslsl, you'll notice that I just see those files. Where am I, folks? Where am I currently? I'm in example2 src under my folder, and these are the files in it. Nothing odd has happened yet, okay? But let's go and import these files into the repository. Let's add these files to the repository, ladies and gentlemen. And so I just did an svn import. I added the current folder, and I added it to this Subversion location. Just to be clear, this svn URL, in case you don't remember it, is this thing here. I could have typed it out. And I told it, hey, this is the initial import. And you notice it added it in, okay? Okay, great. So imagine I'm doing that on one machine. And now I'm going to go up, so I'm now in the main repository, and I'm going to actually create a work directory, okay? This is as if I'm on a separate machine, okay? Imagine that I'm on a separate machine, and maybe I'm even a separate person. So I've added this, I've created this project. And now imagine I'm on a separate machine, and I want to get access to this project. So what I can do here is okay, I'm on this machine. I want to now tap into this project. I want to tap into this project that I created earlier. So I do this svn checkout, folks. So I didn't put it there, svn checkout. And what does that do? That sort of subscribes me, as it were, you could think of it, to this repository project, okay? So it's getting me my makefile, foo, and bar here, okay? So I can do an ls-l, and I'll see that these are here. If I do an ls-la, I'll actually see that there's a hidden folder called .svn, where it's keeping track of some additional information here, okay? Now let's suppose I want to go modify these things. After all, I'm on some other machine. I want to modify one of these files. So I'm going to put an extra line here. So extra comment in foo.c, okay? In foo, extra comment, I'll just say, at the end of foo.c, okay? So now, ladies and gentlemen, I've got the same things here, but my foo.c locally, on my current machine, it has foo.c. Does the repository know about it at this point? No, the repository does not know about it. I've just modified it here, okay? And maybe I'll then ask, okay, what's sort of the situation between my machine and the latest version? Okay, it says, well, the makefile is the same, bar is the same, but foo, I've actually modified here. I've actually modified it on my machine. It's a different version than is on the repository, which is only version 1. And I can ask, well, what's the difference between them? And it says, okay, in foo.c, there's now this extra comment. Okay, I could now commit to this. I can now commit my changes. What is that going to do, ladies and gentlemen, to commit my changes? It's going to update the repository with me, and I'm giving a reason. I'm giving some description, some metadata, saying, hey, what did I do here? What is the meaning of this change? In this case, it's particularly simple. And you see it says sending foo.c. Why didn't it send bar.c, ladies and gentlemen? Because I didn't change it. I could then do a status, and I'll see no differences here, folks. There's no differences between the two, except that here, so the latest version on the repository and on my local machine is version 2 of foo.c, but only version 1s of the others. I could do svn update, and that's going to be updating my current directory, and I can do again a status here, and I'll see, okay, everything on my machine is now version 2. It's earmarked down from version 2 of this. Okay, and the final thing I'll show here is I'm going to just create a baz.c, and this is important for your lab. I'm going to add this in. I've just added it, folks, And now I could say, okay, what's the status? And you'll see the status is I've added Baz on my machine. And then to commit it, to send that up to the server, I put it on the server here. And by committing this, now it's on the server, and I could do an SVN status and go look what's on the server, and I can see Baz has been placed on the server. What's on my machine? Well, I've got some different versions. I can do an SVN update. Okay, that's all we have for now. I hope that's of help for the lab.